to share with you the key I wish I knew years ago when I first started trying to fix my own hip mobility and eventually that of my clients as well. You see, so many times when people have a limitation in a given area of hip mobility, let's say internal or external rotation range of motion, they think they need to do a bunch of different drills that try to hammer that specific thing. For example, if they have limited internal rotation, then they think they need to do a bunch of things to open up internal rotation space and move in and out of that position. But here's the thing, that can be the exact opposite of what you need. It can actually make your problem worse, or at best, do absolutely nothing. You may be surprised to hear that a lot of people don't need more of the thing that they don't have. What they actually commonly need is more of the opposite position. But bear with me for a second, because I know that sounds confusing. Let's use the hips because it's probably the easiest example, and well, that's what I'm holding right now. Your femur or leg bone only has so much room to move within the hip socket. Internal rotation involves the ball of the femur right here sliding back within the hip socket. So there's only so much range it has to move back. But what happens if you're already started in a position of relative internal rotation? That you're going to show on a range of motion test that you have a limitation, but it might not be because you are so externally rotated you can't internally rotate. It might be because you can't get somewhere you're trying to go if you're already there. You see, when the hips lack mobility, generally what happens is that the spine makes up for that lack of mobility by moving the entire pelvis. If I just arched or rounded my low back, I would be moving through my low back, and my pelvis would be moving as one unit as a result of that. If my foot is fixated to the floor, that changes the position of my femur within my hip socket. Now here's how to tie them together. If I lack internal rotation mobility, then my spine usually is going to help me create that strategy by moving into anterior pelvic tilt. It may even hold me there within my posture. That initial movement into anterior pelvic tilt slides the femur further back within the hip socket, as you can see right here. Now, as a disclaimer, there are a lot of different variations of anterior pelvic tilt. This is just one common one that we see. So now let's consider if I were to assess my internal rotation mobility and I'm constantly stuck in a position of anterior pelvic tilt, I might not have any more room to go into more internal rotation. A better solution would entail one of two things, if not both. First, to improve the position of the pelvis as a whole, to help it access a more neutral state. You can see how if I moved from an anterior pelvic tilt to more of a neutral pelvis, that would slide the femur relatively forward in the hip socket, giving me more external rotation space that then started to move into more internal rotation space. This is the 90-90 hip lift with the wall hold. To set up for this, we're going to get in a position where our feet are flat on the wall and we have a perfect right angle at both our knees right here and our hips relative to our trunk. Now, we also have a little shelf right here underneath the heels. It's not necessary if you don't have something like this, but I find it just really helps for people to have something to dig their heels down into. But again, you don't have to do it. You could just do it with your feet flat on the wall and with the intention of dragging your heels down. So let's get into it. What we need to do to set up is find the right foot contacts on both sides. We want to make sure that while our knees are in line with our feet and our hips, we can maintain our heels, obviously, into the wall, but also the base of our big toe and base of the little toe evenly on both sides. I would say about 60% of your emphasis is on your heels. The other 40% is evenly spread between those 2 points. Now, Sabrina should also put a little ball in between her mid to upper thighs right there. That ball or object should be wide enough to allow her knees to stay in line with her feet and also her hips. And she's got her hands linked together on her low rib cage. So she should feel her whole low back flat here. The last thing she's going to do to set up properly is make sure her chin is passively pointing at the ceiling. So she's going to tip her head back just a little bit right there. Perfect. Okay, now she's going to check in. Do I feel my foot contacts? Do I feel like my whole body's relaxed? The answer is yes. All she's going to do to initiate this exercise is keeping her whole foot flat and relaxed, but focusing on the heels. She's going to dig down into this thing, or just her feet down on the wall. Her feet aren't actually going to move, but the intention of dragging her feet and heels in particular down is going to slightly lift her tailbone off of the ground. Her low back is going to stay flat, but that little tailbone is going to kind of curve off of the ground into what we call a posterior pelvic tilt. The action of doing this is going to engage her hamstrings on both sides, hopefully as evenly as possible. And then she's in the right position. She's just going to now breathe in through her nose, out through her mouth. She's just going to fully exhale through her mouth with an open mouth and relaxed jaw. Let the air fall out of her. And then at the end of that 5 to 10 second exhale, she's going to pause, close her mouth, and then very gently inhale through her nose. Keep your chin to the ceiling. Let the air fall into her rib cage. Just the idea there. The question is always, what is the least amount of tension I can do this exercise with and still do the right things, which is maintenance of those contacts, of the focus of
welcome back. Now we will solve some questions. Now let's do this question first. Number of subsequences that satisfy the given some condition. You are given an array of integers like nums and you have this integer target. Return the number of non-empty subsequences of nums such that the sum of the minimum and maximum element on it is less than or equal to target. Since the answer may be too large, return it in modulo. Okay. So we have to return the number of subsequences in which the sum of the smallest and maximum element in that subsequence is less than or equal to target, right? Okay. So let's reset this first. What we can do, let's analyze here, and we can take this question. We can take this example, right? How we can go about it? Okay. Okay, we have this array. So we know already like what is subsequence. So we have two options: take and not take. Let's say we start from this index, right? We can take it, or we can not take it, right? When we take it, then minimum and the maximum is 3, target is 10. So min plus max is all both are 3, so 6. So we have to count that also, and this is one sequence, and one is not take. Then we have other than 3 here, take and not take. So 3 plus 3 again here, 6, right? Here is not take. When it is take, then we can have 3 comma 3 again, 3 plus 3 here. This is not take, right? Then it is 3 only, and it is 3. Okay. After this we can have take and not take, take and not take, which is okay. Okay, then 6. So we go like this, right? So let's say we are running a function, we have array and we have minimum of that, the maximum of that, right? Okay, and target and I index, right? So if we are taking take, right? If we are taking this, when we will take only min is this and max is this, so in these cases, like what we can do, where we have to save the min and max, right? Because we are starting from this, so we are taking that, right? So okay, so we can calculate min max is here also. So what is min is equal to 3, max is equal to 3, right, in that case. And after that, if we want to take, okay, so in case of only take, right, then we can calculate min comma max, and which are 3, and because both are less than target, then what we can do, we can work with this. So when we will know that it is less than target, right? If it is take, alright, after it also goes like this, take, not take, take, not take. We have to go like that. When we reach the end, right? When we reach the end of array, then we go if, then we count, right? Right. Okay. So we have to return back 1. Take plus, now take, right? Then we have to return 1 in that place. Okay. So I think we are going to do this like that. Is we will return a function which is taking nums, which is taking target, taking index 0, which is taking min, right? And we have our what is min? And min is 189 into max is minus 1, right? I guess we have to override function here, right? Which is return end. It will take this nums array as reference here, and the target also, and I into min, and let's see, right? We have to 1 is into take is equal to 0, right? Is we are taking this. So take is equal to of your nums and we are getting target, and integer I plus 1. Min is min of many, comma we are taking right nums I, right, comma max is maxi, comma nums I, right. If we are not taking into not take is equal to f of nums, which is target plus 1 min, maxi, right. Okay, now return take plus not take, I think. And what is this case? If I is equal to nums with size, right, right, we can do like this. So we can minus 1. Now I will do return 1. And many plus maxi. Okay, so we have to go for like this only. But I think maxi is equal to target. Then we, in this case, we will return 1. Right. Before that, we have to check like if it is if I is equal to not the size and many is equal to 199 and because many or maxi is not didn't take anything, or maxi minus 199. In that case, I think we have to return 0 in that case, right? Okay. Can we, I think we are putting it correctly, but compilation error is there. Why it's so? Okay. Get I plus 1. We have runtime error, right? Okay. what problem we have guys here. Let's see. What's the problem? So okay. I have to do this. What is it? No, I don't know the two pointer right now. I just want this. Okay, so I think it's not the problem of that. I think it's a problem of the overflow here. I have this problem. Can you clarify what is this? Leaky viscous white. So in a research in the array like that, and due to pick some elements, so many maxi are valid numbers. If two false, greater than okay. Well, let me try this also. A equal to num size, asking for num size is asking for element that is strictly out of bounds. Okay. Prevention crisis. Alright. So see one that we have a condition. Okay. So I think we have like this where we are asking. I don't know, but okay. Is not equal to this. Not equal to this. and many plus maxi is equal to target, right? Then return 1 is return 0, right? This is good now. Okay, it's going nice, a bit material, but we can take care of it. Here 15, only 15 out of 10. Okay, let me take what we are going to take and not take. We have this target, if this runs. Okay, so we have to go over to the array, right? Target is already there, right? So how is the define this array? Because target is there, let's say we define it target array, right? And we have this elements array, right? I, j, target is not changing, right? Target is fixed. Okay, we are just changing this. Take and not take. Only one array will let you know. Right, so we can define like this. Okay. After that we have something. We have something like that. We have something like that. We have something like 3. How many after this? We are just increasing, right? So let me write. We have vector array, vector of int which is called dp of size what? Of size n. Now the size. Okay. After that we have this. And comma margin. Okay. We are passing details, right? Like this. Like this. If dp of I is not equal to -1, return dp of I and TP and it is also right. Now we are up to, I think, oh yeah, answer should be cause I know why it's this. We have to take that into here. Why did it? Let's analyze this also. So do we have to delete so okay, so what we have to draw some lines, right? So if we are doing this for target or something like that, but let's say this is target, right? These are the elements. 0, 1, 2, 3, 4 like that. If you are at index this, we have two options, take and not take, right? Can not take. So we are going deep, and after all this recursion, we return something like, okay, so on 0, take plus not take, we have something, right? 1 or 2 or something. We are at 1, take and not take after that, 1. Okay. I think it's a good idea, but what is the problem in this? Expected is 4 and output is 8. Okay. And case 2, 6, 64, 61. Okay. So are we giving extra? Okay, alright. So we are adding, right? We are adding more. What could be the possible problem? Let me ask to the guru. Because only one is okay. So compare nums alpha nums at target 8 and 10 is 10. Okay. Left pointer, right pointer is 4. So next is now which is less is the one right pointer. Okay, it's 16. 3, 7, 9, 11, 10. Right. You just go into state collector. Your code will now run fast, but it will completely wrong answer. Let's break down the mathematical reason why the DP area is currently corrupting the timeline. Why DP is physically impossible for this problem. How to finally conquer it. Right. So look at your cache array like that. Your cache array like this. You are telling a computer if you ever visited DSA before it and the exact same number. I got last 10. The world scenario, imagine we have like this, the target is 10. Your recursive function decides to take 2 and it drives index 2, the number with minimum is 10. Is at 4. And saves 10s. And when we computer looks at it 2, it seems number 4 sitting here. Oh, I already know the answer, it was 4, okay. But wait, okay. Memory lamp code. To fix the state collapse, your DPI must perfectly remember every variable that makes a state and unique. Okay, so minimax already we need 3D area in that case. And look at the constraint in it code. Area size is 10 to 5, max value is like this. 3D material need to size this, that requires roughly that amount of lamp. Okay. The math shortcut one way to pass is we must abandon tracking every element individually, right? Because the problem only checks minimum plus maximum less than is equal to target. The original order of the array does not matter. You are not allowed to sort the array. Alright, once sorted, you can use a pure mathematic. You are allowed to. Okay, we can sort the array here. You can use a pure mathematical solver millions of persistently. If your left pointer is 2 and your right pointer is 8, this is 2 plus 8, you know the boundary is valid. Every element sitting between them can either be taken or not taken. Okay, so taken choices. If there are 3 flexible elements in the middle, if there are 3 flexible minerals, the total valid subset you can make is exactly to count 3, which is 8. Okay, you just calculate 8 recursive branches. Okay, so 2 to the power left minus right. Okay. Okay. All right. So we just need to sort the array first, right? Then while left is less than equal to right. Control. Okay. Plus left plus because but why we took the power? Okay. Okay, this is like just okay, this is one of the ways. Let me code it, guys. It is like okay, so what we need to do first, we have to sort this, right? Sort nums dot begin left and right. We have enter left equal to 0. We have enter right equal to -1. 4. Okay. Left plus left. Okay. While left is less than or equal to right, what we have to do? Okay. If nonce of left plus nonce of right less than equal to target, then sequence is equal to sequence sequence plus equal to power of 2 comma right minus left, right. If it is like this, else, and after that we have to right plus plus. If it is not the case, we have to do right minus minus right, and the sequence is equal to 0 here into mode, what is the mode? Let go to description. What mode is equal to 1 9 plus 7, right? Okay, so sequence plus like this. Good. Just return sequences. Are we getting the right answer or not? What? Plus power of 2 minus what is the receiver? What I am doing wrong? Can you tell me, bro? Okay. To solve mathematical without striving, we must use a famous algorithm called fast exponential. Okay. Alright, so we have to implement this array, which is long power base and exponential node. Okay. Now result is 1, base is modulo, base modulo 1, exponential greater than 0 will let me implement this also. It will take more power we are implementing. Okay. Long more power. It will take this exponent so that is equal to 1. Is this one? Result is 1, right? Result is 1. Then this is this. Okay. Result is equal to 1. Base modulo 1. Then what? While exponent is greater than 0, if the exponent is odd, multiply the base into the result. Okay. Multiply the base into the result. If it is even, then base into base square mod. If exponent mod 2 is equal to 1, then result equal to result to base mod amount, right? And after that as for the base and how the exponent. After that base is equal to base mod. Right. While xp is 0, right? Can I do it now? We can move this. Okay. What's the problem now? Okay, so if we have alternates base experimental mode. Okay. What is the problem? Something from our mode. Okay. Right. Now it's doing fine. Okay. After that, what is the problem that we have to do? We have done this problem. Now we have this problem, which is partition with qubit difference. Okay. We have given ARR and integer diff. Count the number of ways to partition the array into subsets such that the difference between their sums correct difference. It's a medium problem, we can do it, but I will make it for 5 minutes. We are back and let's start the question again. What is the question is? We have given an array and desired difference. Count the number of ways to partition the array into two subsets. Such that reference between their sums is equal to diff. The partition of array means dividing array into two subsets. Says as such that equal to the original array and element is only one of the subset. Okay. So let's take this example. We can take this example here and let's take it to the left. Here. There is only one possible partition. Okay, so we have 5, 2, 6 and 4. We have difference equal to 3. So we can S1 and S2. S1 plus S2 is equal to total should be there, right? If it is like there, total, and S1 minus S2 is equal to diff, right? So if we add them both, 2 of S1 is equal to total plus diff, and S1 is equal to total plus diff by 2, like this. Okay. So if we can what we have to do in the question? Count the number of ways partition. Okay, so we have to count the number of ways to partition. Alright. So we have to find like, okay, if we have to find the subsets in array such that subset sum is equal to like, let's say it is odd, right? Total plus diff is odd. Then what? Let's say, let's take this example only. 5, 2, 6, 4, 3, total is what? 5 plus 2, 7, 17, it is even. But what if it is odd? Right? Instead it was 4, it was 21. Can we partition that? Because let's say if it is even, right? To get even difference, either both sum are even or both are odd. So both sum S1 and S2 are even, right? Both are even, then S total is even. If both are odd, then again total is odd. But if either of them is even and odd, then total is odd. If total is odd, right? If total is odd here, then one sum is even, one sum is odd, right? Yeah. Even and odd. But when we define even minus odd, then difference must be odd, but it is even here. Let's say total is even and difference is odd, then total will be difference this will be odd. But if it is even, what is the case of even? Both S1 and S2 even, S1 and S2 odd. If both are odd, right? If both are odd, then difference is always even. 9 minus 3 6, like that. If both are even, difference is even. So it is not possible that total is even and difference is odd. What if total is also odd? Then this sum will become even, right? Let's say it is odd and it is even. If it is odd, right, then one is even, one is odd, then difference can't be odd or even, it's always odd. So our hypothesis is correct. If it is not possible, what we have to return? Return what? Return 0 in that case. Okay. So first count the total. 0 for enter equal to 0, I less than the sides. Total plus is equal to I. Target is equal to this total plus if target is from the hand is odd, turn 0. Okay, we have this target. If it is not, then we have to else. If it is even, now we can count this. New target will be equal to target by 2, right? Okay, so we have to find the subset sum, count that, take, not take, direct we can go to degree solution also, take and not take, target, right? We can go to tabulation method also. Target 0. Okay, we are going to tabulation. Into 0, I less than total size plus plus vector of vector dt, right? int manager dot size and comma dot font target and comma password. Your target is 0 4 and I is equal to 0. Less than 1 I plus plus dp of I comma 0 equal to 1, right? We can get that. Now after that 4 into 0 equal to target run I 0 minus that, and after that dp of the I comma 0 is equal to take plus nothing, right? If we are taking this element, okay, if j is equal to error of I, right, then dp of j so I is okay, we have to initialize that case also. For and I is equal to 0 1 I plus plus if I is equal to target dp of 0 comma I is equal to 1. We can initialize this 1, okay, equal to dp of 1 plus dp of I minus 1 comma j right? Else dp of I comma j is equal to dp of minus 1 comma j, and after all of this we can return dp of what? Target is there, but minus 1 comma target. Okay. D your output is 2, expected output is this. Alright. Minus 1 j minus I of I. Okay. Still dp of I minus 1 comma j plus. Is this the correct form? No. Minus 3 is there, okay. How do we get the subsets, guys? Take note, it is not take note. Let me divide and view. Now we have to insert one more page. So what we are doing is that we have some target, we have some elements, right? Target is there. So we are at first element. In this subset we can take it or not take it. So what are we doing here, guys? I think one mistake I did is -1. I think I should initialize it with 0, right? Yeah. Now that's then equal to run plus run no. So we have to increase the contract like this. Output is 7 here. Hmm. I don't think because so target we are at this index of array, right? What we can do is this index. Either we can take it or not take it. So we are taking it. Okay. What is less than okay, target is okay. We can't do 1 plus here because so subset sum is not like this, guys. I think. Subsequence, okay, so element I, right? So target minus error I. If it is 0, we can take from here, right? One way. And we go here. Okay, we have target. So 0 here, 0 into 1 here. J if I am here at this element and we are target, it was 10, it was 3, 0, it was 7, right? 7, 3, 1. Okay, so it was 7, right? So 7 was 1. Now it is 3. It is 0. 3, 1. Right? So it was 0, right? 3, 1, 7, which is 1. And So int a equal to 0, int not equal to 0. Here is equal to this, not take is equal to this. Here I comma j will take plus not take what not Control C here, Control V. Problem is this. What is this tool? Images, okay. Can I try this tool? Create image of Indian flag one. Create image of solar system from scope. If I will drive the absolute most important method following the problem, you correctly calculate the drift flow and like that. Your code is available mix of 2D and 1D architecture, man at type. Right. Just look. We have any problems, but okay, we will find out. Just first look at the image. Jupiter, Neptune, Sun is there. Great. let's go for this. What we have? The logic. Look at your inner condition. For int j is target, j is greater than array, and j minus. Because you strictly stop the loop when I reach a j. Okay, the condition of this yes is always true because we are stopping there. Okay, utilize TPI of 0. This works when only have positive numbers, but what if you have array has zeros? Okay. If we have subset 5 that sums to 5, you have 0 a 0 available, you can make 5 or 5 comma 0. Both sum to 5. 0 effectively doubles the number of array subsets by forcing columns 0. Okay. Well, you break the combinatorics of zeros. Okay. Base case step you wrote like this: inside a loop, since I represents the array index, you are accidentally writing 1 to random columns instead of just a specific column value. Okay. Alright. Yeah, this is the mistake I have done, I think. Profile like this, we have to do this. And this gives overall circumference to grow chances, so more we have to take. You changed the loop structure for this optimization loop words down to values into the successfully commit to one array. Okay. Everything dp okay, dpj 0 is my reverse. dpj naturally. Set a 0 using dpj. Okay, okay, we have taken out, we have taken total less than 0 or like this, return 0. Okay, and like this also, vector in target. Okay, dp0 is 1. Alright, yeah, target is minus, dpj is below dpj, target like that. Alright, total minus 50 is 0. We did handle the combinatorics. And now total way to be left at dpj plus dp of with that. Okay, like we are solving like this. I think vector dp target dp like this, and we don't need this also, we don't need this also. dp of 0 is equal to 1, I think. Alright. So 0. Target minus whatever, but we are taking example. We have this condition already here. dp of j is equal to dp of j plus dp of j minus 0.5 right. Now we move into 199 plus 7 and what do you say now? Okay. No. Target outlet 1 0. I think it's done and dusted now. We have done this question, and next we will go for the question which is this. Right, yes. After this, it's a easy question. What is this? Assign cookies. Can you do that? This easy question quite. What is it? Wait. Read code right. Assign cookies. Assume you are an awesome parent and want to give each children some cookies, but you should give each child at most one cookie. At most one cookie. At most one cookie. Okay. Each child I has a great factor of GI, which is so what is the question here? Each child has a great factor of GI, okay, which means I have a cookie that child will content with. Each cookie J is size. If size of cookie is greater than J, then we can assign it I, and the child I will be content. Your goal is to make sure the number of contents filtered and output the maximum. Okay. Okay, we have some cookies and we have some like this. Let's take this example. We have two childs which are grade of 1 and 2. We have this 1, 2 and 3. Can we fulfill this? Yes. Can we fulfill this? Can we fulfill by this to this? Yes. Yes. and can be fulfilled with this, yes. So 1 plus 1 like this, 1 plus 1, 2, we will equal 2 children, okay. Can we go to this, yes, 1, 2, okay. If let's say it's all 1, 1, 1, right? It's all 1. Can you go to this, yes? There's no 0. Fill this, yes. Remove this, so we can't do, okay, we can just get to place 1, 1, get for application, right? This, okay. Can we do this like that? You see each question, right? We have ADP, damage, dot size, damage, dot size, right, and we have vector of int of m plus 1, comma vector of int, comma plus 1, comma 0, I think, and 0, 0 I is less than equal to m plus plus 4 and 0, 0 equal to m plus plus, right, then after it f g s of j is less than equal to, we can say, what is I is row, right, element. So if s of I is greater than equal to g of j, then dp of I comma j is equal to 1 plus dp of I minus 1 comma j minus 1, else dp of I minus 1 minus 1, and we are one and 1, well, we have to compare like this here, okay, and for intro equal to 0, then I plus plus 4 and 0, I less than minus plus, if I is equal to 0, return degree of 1.9 and I think no. Okay, we can comment this out, then we can run it. GS and here I can do this and what happened to it? M is G, so I is G, right? Okay, that's a problem. M is G, which is grid. I think M should be this and S should be G like this. Alright. Okay, one case is running, one case is not. 1 1. G 1 2 3 S 1 1. G is 1 2 3 1 1. It's first it's all 0 0 0 0 0 0 0. So can we do this? Yes. So 0 to 7 1. So now, so grid is more, right? If a grid is more, then we can do that. 0 0 1 1 0 0. No, we can take from here 1 1. So when we are here, so we are taking 0 from here, right? We are not taking 0. Okay, so we can take this. dp of I minus 1 comma j comma dp of I comma j minus 1. We are taking the max out of it. Whatever. Wait. Both test keys run. Let's try to submit this. Speeding up. Wrong answer. Okay. Why it's wrong answer? We have to take it to the Supreme Court. 0 0 0 we can initialize as 1, right? Nice. Okay, we are sorting it. Okay, so it's a very great day. Size 1, okay. Yeah, step forward to 1. Cookie here, grid is there. Forward 3, 2. You could have done natural also, okay. So what was the error we found? TLE or wrong answer we found, right? Give me correct deep solution. Give me correct deep solution first. Bro. Don't play with me. Like a fish. Okay. So what I need now is this. We have to do. Okay. Let me see. Can I submit this now? Okay, time limit exceeded. Okay, now I need this quantifies solution. I can do this. Okay. Left, right, no. I and J is there. Okay. No DP needed here. And I is equal to 0. And J is equal to 0. Okay. While I is less than M and J is less than M. Okay, to continue. And count equal to 0 here. You have to count it right. Now, if G of I is less than equal to S of J. J is I is for what? S, right? So I is for S, so we have to J is for N, which is G. If it is like this, then count plus plus G. Right. Okay, else if, then what we can do? Else if greedy is greater than s of I. So because if it is greedy, right? So greedy is greater than, so we have to another I plus b. Return count. What happened for just a minute? Okay, it's done, guys. Done and dusted. Assign cookies is done. Minimum coins, I will do them later. I am going for the lunch, so I will be back from control shift. in